Hello, everyone. Welcome to our episode on Matrices transformation. Today, you're with me, Mrs. Rhodes-Grierson. Let us look at Math Unlocked. What are we doing today? So, our main topic is matrices transformation, which would indicate that one, you already learned matrices, two, you already learned transformation. So today we want to combine the two to look at how do we use a matrix to do a transformation. Now, for our first lesson, we're going to look at the concept of reflection. So the first transformation we're looking at is the reflection transformation. And you do take note that I have mirror line here, which is indicating that in order to do a reflection, there must be a mirror line. So what does matrices transformation entail? If you're looking at to transform a point or an object, so a point, notice I have on my small Cartesian plane here, I have the point A, which is at 1, 0, the point B, which is at 0, 1. These 2 points are representing that on my Cartesian plane, if I had a point on the x-axis, 1 unit away from the origin, being A, B, 1 unit away from the origin. Those 2 points, if I should take them from the Cartesian plane and write them in a matrix, your coordinates are represented in a column. So A would be represented as 1, 0, B would be represented as 0, 1, and this now is a matrix representing the 2 points A and B. Now this should look like something to you. If it doesn't, it means that you need to go and review matrices again. But to just remind you, this matrix here is what we call our identity matrix. Or we could call it our unit matrix. So it is representing that each point is 1 unit away from the origin. Now, what do I want to explore with you is how do I obtain the particular matrix that would be used to represent a reflection. And we're going to start with the line, the mirror line, the x-axis. What I'm doing here is that I want to obtain the 2 by 2 matrix that I would use if I wanted to transform any point using an x-axis reflection, and I want to transform it using a matrix. So I'm trying to obtain that matrix that would do that for me, right? So come along. I'm on the Cartesian plane and I'm at the point A. A is standing on the x-axis. If you recall reflection, you would know that if you're reflecting a point in the x-axis and the point is already on the x-axis, it means that the point cannot move, because to reflect means that the object and the image must be the same distance from the mirror. Given that the point is on the mirror, it would remain the same position, so A prime would still be at 1, 0. What I'm doing here is creating the matrix that would represent any reflection in the x-axis. I've obtained 2 coordinates already, and now need to observe B. Observing point B, I'm looking at what would be the matrix. I'm trying to conclude the matrix that would be the matrix that would represent an x-axis reflection. So now I'm looking at point B. Point B is 1 unit above the x-axis. For a reflection, it means that it must be a flip. It must be flipped across the mirror in the opposite direction. So that means if it's 1 unit above, it would go 1 unit below, which means that B prime would be at this location here, representing a coordinate, x reading first, that's 0, y reading second, that's -1. What does that mean for all of us? It means that this matrix that I've just created is the matrix that I'll use for a reflection in the x-axis given any point or any object. So let's see if we could explore that a little bit more. Let's say I have the point P being at 2, 3. And I want to use the matrix here to transform this point. use a matrix to do a transformation means I'm multiplying the point by the matrix. The matrix is written on my left. The point is written on my right. So I have 1, 0, 0, negative 1, which represents a reflection in the x-axis, being applied to the point 2, negative 2, 3, and this will be written as a column. So your coordinate must be written as a column if you're going to use a matrix to multiply that coordinate. And then we will go back to what do you know about matrices multiplication, which means that you would have had to learn all the aspects of matrices first before you are doing matrices transformation. So to multiply two matrices, it means that the rows from the first will multiply the column from the second, or columns, given that I may have an entire image being transformed, which means that I would have had an entire shape, which means that I'd have multiple points along the matrix. This is just a single point. So I'll use row 1 to multiply column 1. What will I obtain? 1 times 2, that's 2, plus 0 times 3, still 0. So the first number would have been 2. Row 2 times column 1, 0 times 2, that's still 0. Negative 1 times 3, that's negative 3. This means that P prime would take up the coordinate 2, negative 3, and I'm writing that now in coordinate form. P prime would be at 2, negative 3. So what a matrix does for transformation is that I use the matrix to multiply the coordinates written in column format, and I would have obtained the matrix from here, which represents this matrix is the matrix for an x-axis reflection. Alright guys, so we would have created the matrix that would represent a reflection in the x-axis. Now we want to create the matrix that would represent a reflection in the y-axis. So notice we're creating it, So we're using the information of the unit matrix that represents the points A and B. A being 1 unit from 0 on the x-axis, B being 1 unit from 0 on the y-axis. So let's explore. I want to create this 2 by 2 matrix that represents this reflection in the y-axis, and after creating it, I can use it for all reflections in the y-axis where I want to transform a point or an object using this matrix. So let's explore A, and where A prime. What is the matrix that would be used to reflect A prime in the y-axis? Now, seeing that A is 1 unit to the right of the y-axis being the mirror, for a reflection, we know that it must be a flip, so it must go in the opposite direction. So since A was to the right, it means that A prime would go to the left. And it must be symmetrical, so if it's 1 unit right, it would be 1 unit left. What then would have been the coordinates of A prime? That's negative 1, 0. Recall that we must represent our x first and then our y. Looking at B, where is B? B is actually on the mirror line. Remember that our mirror line is the y-axis. Since B is on the mirror line, following from what we did when we were reflecting in the x-axis, any point that is on the mirror, if you do a reflection, it must remain there, because when we do a reflection, the mirror line acts as a line of symmetry. Since it's on the mirror, it cannot go anywhere, which means that the coordinates here for B prime would still be 0, 1. What did I just create? I created the matrix that would represent a reflection in the y-axis. That means this matrix will be used for all reflection if I'm going to use a matrix to reflect a point or an object in the y-axis. Now that we would have created those two, let us just explore the other two quickly. What if I wanted to create the matrix for a reflection in the line y equal x? We're going to create that. So let's see. Remember, the line y equal x is a slant line that represents that the x and y coordinates on the line are equal to each other. So if x is 1, y is 1. If x was 2, y was 2, so on and so forth. So let's look at if I reflected X in this line, and it must act as a line of symmetry. So it means that if A is here, then going across in the opposite direction, it must be perpendicular. That means that A would fall where B is. What then would have been the numbers here? If A is reflected in the mirror line and falls where B is, it means that A prime would be at 0, 1. Let's look at B prime. If B is here and I reflect it in the mirror, it means that it would fall on the opposite side, meaning fall where A is. That means that B prime would be 1, 0. Now I've just created easily the matrix that represents a reflection in the line y equal x. What would I do with this? I'll use it to multiply any point that is going to be a reflection in the line y equal x to create my image, which would have now been obtaining where's the location of the new shape or the new point that I would have created. So let's just do the last one. Let's do the line y equal negative x. You can start checking it for yourselves. If you recall where the line goes, how does it look? The line y equal negative x must be a slant line or in the opposite direction here. Y equals negative x. What am I doing with that? I want to see what would have been the matrix that represents this type of transformation. Still 2 by 2. I'm obtaining A prime, B prime. Let's look what is happening here. Here is A. Here is the mirror. My line isn't perfect, but it's a semblance of what it should look like. Now here is A, here is the mirror. Remember that when you reflect, it should go on the opposite side of the mirror. Let me see if I can fix up my mirror line a little bit here. All right. It should go on the opposite side of the mirror, which means, and also perpendicular, if A is here, it would fall over here. What's this location? The location of A prime would have been, remember we read X first, then Y second, so that's 0, negative 1. Let's check out B. B is here, falling across, perpendicular line. B prime would fall here. Where's this location? Reading X first, that's negative 1. Y second, that is 0. So what I've just created are the 4 matrices that would represent or are different reflections in the various mirror lines. All right, I hope that you would have understood that all. You can like, comment, make your ask your questions if necessary. So we would have covered reflection using transformation.